Hello, this is my showcase of the tool that I've created whilst working at Framestore. This tool is it's titled a camera ingestion tool, and what that essentially means is it takes the animation data from a camera that we've been given by a vendor, or a source camera in this case, and copies and transfers that information onto a Framestore camera. This version of the tool has been changed and altered to function with Maya standard cameras instead of Framestore assets, which means it's changed some of the processes and some of the variables and inputs that it needs to run. In this case, most of the camera attributes. Some of them are different in comparison to what the attributes we have are on our Framestore cameras, and the way they are bound together is slightly different as well. But I'll run through what the tool actually does now. I have two versions of the tool up here. I've got one in the script editor to my left, and I've got an actual shelf tool that I've created of the same script, so it can then be ran using the shelves. It's a simple single function script. It takes one input, in this case a source camera, which we have here in the scene, camera 1. You can see this camera has a bunch of keyframes, and those keyframes relate to rotational and translational values. We also have some other attributes here. In this case, as it's a camera, it has stuff like, horizontal film aperture and f-stop and focus distance and focal length, stuff like that. And what the goal of the tool is to transfer all of those values onto one of our cameras, and that is what we're going to be getting. So if I look through the source camera at the moment, that is what happens, and that is what we want our camera to do. So as I mentioned previously, this script has been changed and altered to work with my cameras instead, and not Framestore assets. So it will be slightly different to what is actually used in-house. But let me run through it with you now. So we do the standard import commands and import mel, as we are going to be using some mel eval for this. It's one simple command for deactivating and reactivating the viewport to help us when we get to the bake stage of this tool. This tool takes one input, which is a source camera, which uses the cmds.list selection tool. So that basically means you have to have the source camera selected, which saves any confusion about selecting an incorrect, or looking through an incorrect camera, or having the incorrect camera baked, basically ingested in this case. So it takes a source camera which you have selected, and here we have a list of attributes, which are all the attributes that a Maya standard camera has. So we have the translational and rotational attributes. We've got horizontal film aperture and vertical film aperture, and lens squeeze ratio, f-stop, focus distance, shutter angle, film fit, pre-scale, post-scale, vertical film offset, and horizontal film offset. And those are all values that allow the camera to look like this, essentially. If I show you that is what you see through the camera, and all of these attributes help make it look like that. So we've outlined the list of attributes, and we now have the very first thing the tool does is it turns off the viewport. So it deactivates the viewport. So if I run this function, or this command as a standalone, all it will do is that. So we now don't have a viewport, and this is because we do a few bakes throughout this tool, and because we need to bake, the bake command requires a simulation flag, which requires it to go through each frame and evaluate each frame as it passes through. Now, for this scene and the purposes of this scene, it wouldn't take very long, even if we didn't have this function active, or this command active. But as you can imagine, with heavy scenes that we would be working with in-house, that can end up taking quite a while, as it has to evaluate every single frame independently. So we do that to save time, basically. So then, once that is deactivated, it creates a camera and assigns that camera to a variable, which we then later use in the tool itself. And after we've done that, we then select the source camera and we use a command here which is playback options. And what this does is it finds the, in this case, we're querying the playback option of the min time. What this does is it goes through and finds the very first keyframe of that is on the source camera. In this case it will be keyframe 1, and it sets that to basically an index in this variable here. It does the same again for the very last frame, so it does min time and max time of the source camera. This allows us to set the bake range that we want, which we'll be using later on in the tool. We're now setting the post-infinity and pre-infinity curve to linear, and what this basically is on the source camera, and what this basically is, if I show you a visual representation of that, so we have the source camera selected, and we go up to Windows, Animation Editors, and Graph Editor. We now have a graph representation of all the keyframes that are on that camera, all the animation data that is on that camera. If I then go to View and select Infinity, you can see it's already set to linear, but I'm going to show you how that happens anyway. You then go to Curves, and you have pre-infinity and post-infinity here. All you want to do is click linear, and post-infinity click linear as well. And what that essentially does is it makes sure that once the first keyframe, or anything before the first keyframe, is set to the same values that these keyframes have, basically. So if they're all set to 0, everything prior will be set to 0, and same for the very last keyframe. Everything will be set to what those values were on the very last keyframe. And what this does is this stops any strange transform data that can sometimes happen on the start frame and end frame of an animation. It can evaluate strangely, it can cause 360-degree rotations to occur and cause things to blow up, and that basically prevents that from happening. So then once that stage is completed, it then runs through and creates a parent constraint of what it does, it constrains the target camera to the source camera, the target camera being the empty camera that we created previously, and the maintain offset flag is set to 0. So what that essentially does is the target camera will be built in at the origin, and it will snap that target camera to the source camera's world space location via a constraint, a parent constraint should I say. And then after that is completed, we now have a connect attribute and a bake for loop. So it runs through the for loop, and for every attribute inside the attribute list, which is up here, it will connect that attribute from the source camera to the target camera, so they have the same values, and it will then bake those out for the frame range that we've specified. And then once it's done that, we then do a secondary bake just to ensure that anything that could be evaluated strangely has been accounted for. And then we set the pre and post infinity, much like we did with the source camera, to the target camera, and then we remove the constraint that was on the target camera, and then we reactivate the viewport panel. And that is the premise of this tool. So now I'm going to run through an example with you. So you select the target camera, or sorry, the source camera. I'm just going to show you that right here. So as you can see, printing that variable there, source camera, outlines camera 1, which is what this camera is, as you can see there. And then if we just cache this function, and we now run the function or call the function, as you can see that happened in a split second, disappeared for a split second. But if we now go into the outliner, we can see there is now a second camera that's been created. And we can see that that camera is also in the exact same place as the source camera. And you'll also notice that there are keyframes on every single frame, which is part of the bake process. And you can see that all these attributes here have been copied over. You can see as it moves through, we have these values, and the values in terms of what the camera shows you are also identical. Just show that in a much more advanced way. So we have the focal length that's keyframed, we also have the camera aperture that's keyframed, and the lens squeeze ratio that's also keyframed. And so that is maintained throughout. Just a visual representation as well. So if we look through camera 1, that is what camera 1 sees. That is the animation on camera 1. And if we now switch to camera 2, and let's make this, let's apply that as well, we now have the exact same animation. So if I switch here to frame 60, just directly halfway through, and switch between the cameras, you can see that they are perfectly identical. And that is what the tool does. So that's running it through the script editor. I'm now going to show you how it runs through using the actual shelf itself. So if I were an animator using this tool, had never used it before, never experienced it, I have no idea what it does, or how it works, should I say. I know what it does, but I have no idea how it works. I would be told to select the camera that I want as the source camera, and then I would click this button here, which is in a custom shelf that I've created, and it will run through and do the camera ingestion for me. And as you can see there, it's created a camera 2. You can also set this up so that it can assign camera 2 to a given name that we would require. So in this case, if I added another variable of tcam name, and then add that in down here as well, like so, we can assign that to, so tcam name, and then we, in this camera here, we go name equals tcam name, like so. I want to get rid of those, and then we assign this, we change this in the actual function here to showcase camera, for instance, just like so. So now if I remove that and we run through this function again, so if I call this and cache it, and we select the source camera that we want, make sure that's assigned to the source camera variable, which it is, and then we run through that. You can now see that the name of the target camera has been changed to Showcase Cam 1, which is exactly what we wanted. I'm going to remove that, as it's not required for the purposes of this showcase. That was just to express how the tool can be altered to account for different variables. If, for instance, a director or a CG supervisor wants those cameras to follow a specific naming convention, that can be set up through the tool as well. And anything else, such as if we want to change any variables, that can also be updated manually as well within the tool function call. And that is my tool. I hope this was informative enough for you to understand what it is, how it works.